lesson 2.1, modeling with expressions. And your EQ is how do you interpret algebraic expressions in terms of their context? Okay, so we're going to look at some vocabulary. Expression, a mathematical phrase that contains operations, numbers, and or variables. And there are two types of expressions. You can have a numerical expression, which is one that contains only numbers, or an algebraic expression, which contains numbers and at least one variable. Terms, these are the parts of an expression that are being added. So if I have an expression like 3x plus 5, 3x is a term and 5 is a term. Coefficient, that is the numerical factor of a variable term. So if I have a term like 3x, 3 is the numerical factor of that term. So 3 is what we call the coefficient. My light's turned off. Sorry. Okay, so that's our vocabulary that we need to be familiar with for today. We're not working with equations right here. These are expressions. If you remember from our last set of notes, we talked about an equation being composed of two expressions and an equal sign. Okay, so whatever you have on the left-hand side is the expression, and whatever you have on the right-hand side is the expression. So today we're looking at the expressions. So this is out of your text, modeling expressions in context. And so this table shows some words and phrases associated with the 4 basic arithmetic operations: addition, subtraction, multiplication, divisions. So these words and phrases, these are here to help you translate story problems into mathematical expressions. So for addition, words like the sum of, added to, plus, more than, increased by, total, altogether, and. That means that you're adding. And examples of that, a number increased by 2. Okay, a number is an unknown. That's where you would use a variable. The sum of n and 2. So both of those would be represented the same way, which is n plus 2, like you can see in number 3. They all mean the same thing, but you'd have n plus 2. For subtraction, your words that help you identify that subtraction is your operation: less than, minus, subtracted from, the difference of, take away, taken from, reduced by. Those are all words that tell you you have subtraction. And so you might see something like the difference of a number and 2, or 2 less than a number. Those would both mean what you see for the third one down, n minus 2. Now, when you see less than, that's telling you to take the two things that you're comparing, and it's actually switching the order. So 2 less than a number means that I have to write the number, in this case n is the variable for it, first, minus sign, and then the 2. Subtraction, you have to be very careful with the order. Addition, you know, it doesn't matter what order you add in, you will get the same answer. Addition is what we call commutable. Subtraction is not commutable, all right, because n minus 2 more than likely has a different value than 2 minus n. So you have to be careful the order with subtraction. Multiplication, words like times, multiplied by, the product of, percent of. These are key words that mean you're going to multiply. An example is the product of 6/10 and a number. Another way to say that is 60% of a number. 60%, to do calculations with percents, you got to change it into a decimal. If you think of the word percent as per 100, then you can think of 60% as the fraction 60 over 100. And you can do that with any percent. You could turn it into a number. You can turn it into a fraction by taking the value and putting it over 100. And you can change it into a decimal by dividing. So 6/10 and 60% are the same value. They represent the same thing. And so if it's of a number, that means you multiply. So that's why on the third line, 6/10 n, 6/10 of a number, it's the product. They're being multiplied together. Division's the last one. Divided by, division of, quotient of, divided into, ratio of. These all mean division. So you might see the quotient of a number and 5, which also means the same as a number divided by 5. And since we don't know what the number is, it's just calling it a number. That's why we're using the variable n. So it'd be n division symbol 5 or n fraction bar 5, where n is in the numerator and 5 is in the denominator. Division is like subtraction in that you have to be very careful about your order. N divided by 5 more than likely does not equal 5 divided by n. Subtraction and division, you have to be careful about the order that you write it down. Addition and multiplication are commutable. It works in either order for those two. Okay. Here's an example, which is also out of your text. Example A is all the way worked out. I'm going to explain it to you. And then example B, we're going to work out together through Pear Deck. So for example A, we have a statement. It says the price of an item plus 6% sales tax. Right? We don't know what the price of the item is. You don't even know what the item is, but it's an unknown and it is a number that we don't know. So we're going to replace that with a variable, and they're using P as the variable. The word plus tells us we're adding. And then 6% means I'm taking 6% of the original price. So if I take 6% and turn it into a number I can do calculations with, 6 in the numerator, 100 in the denominator, that simplifies to 600ths, and then of the price. So it's 600ths times P. And then the expression they gave us there can actually be simplified because P and 600ths P are like terms. We can add their coefficients together. So we're going to do the same thing using that as a model for B. It says the price of a car. Okay, we don't know what kind of car, what it looks like, but it's some amount of money and it's unknown, so we're going to have to represent it with a variable. Plus means we're adding, and then 8.5%, 8 5/10% sales tax. So what can I write? How can I rewrite this information so that I have an expression? You're going to write me a 2-term expression. That's what you're going to share with me, a 2-term expression. Okay, you can use any variable you want. I see a lot of different variables being chosen. That's totally fine. Pick any letter, and then you're gonna have the plus sign. Good. So those of you that have started doing this, you're off to a great start. How do I take 8 5/10%, change it into a decimal, and then show that decimal being multiplied by the original price of the car? You have to be consistent with your variables because they're going to show up 2 times in your expression. And you should use the example to the left to help you figure it out. On the left, we did P plus 0.06P. Well, we still have an unknown variable, but the percent is different. Instead of 6%, we have 8 5/10%. Okay, so another way to take a percent and change it into a decimal. Let me show you guys, okay. So here's a percent that I want to change into a decimal. Okay, so I told you guys one way to think of it is you think of that number per 100. Okay, so if I want to change a percent, I could think of it as being per 100. But this doesn't look right. Okay, so where's my pen? We don't usually have decimals in a fraction. That's strange. So it's division. It's 8 5/10 divided by 100. Another way to think of that is you're literally moving your decimal point to the left twice. Okay, so if I take my decimal point from where it's at and I divide that number by 100, it means I move the decimal 2 times to the left. So the value that I want to work with this is the number we're going to be working with. That decimal 85 thousandths that I have written in purple is equal to, yes, Samantha, it's being recorded, is equal to 8 5/10%. Okay, so those of you that have that in, you're really close. Those of you that haven't written anything yet, Alexis, you got it correct. Nice. I'm going to share this. I'm going to share Alexis's screen. It's right here. First answer. They chose P as the variable, and they added 0.085 times P, the same variable. So this next one down, this is super close, except I need to add a C here at the end. So whatever your variable is, you need to be consistent in using the same variable in your expression. Perfect. C plus 0.085C. N plus 0.085N. That's exactly what you want to do. Okay, so don't worry about correcting it. We're just moving on. So in the line where it was blank before, you now see in pink, we have P plus 85 thousandths times P. So the expression, if I kind of squish it all together, instead of being so spread out, P plus 0 85 hundredths P, that's the expression. And I'm almost done, because if you remember, when you have like terms in an expression, like if you have you could come back to your Google Meet tab if you want to see what I'm showing you guys. I just need to find my picture because I'm presenting, but you have to be able to look at my picture to see what I'm showing you. Okay, so I'm presenting, but then I'm also on your screen because I'm talking. So remember seeing something like this before, 3P plus 4P? 3P and 4P are like terms, so we just add their coefficients. 3P plus 4P is 7P. We're going to do the same thing in our pear deck slide. So back in pear deck, if you have P plus 0.085P, they both have a P in them. They are like terms. So we're going to add their coefficients. And you're going to write what we get. Your answer should be just one term. Nice, Isai. Good job. Nice, Alexis. Good job. Good job, Arabella. So you guys don't be afraid to write the wrong response, okay? Even when I share them, I'm not calling you out, but I need to know where you're confused at so I can help you understand this stuff. Remember, if the variable, if the term is just the variable, like we have here, just P is one of the terms, I don't see a number in front of P, right? But there's actually a number there. It's just invisible. It's implied that there's a 1 right there. It's 1P. Okay. So, last slide. There you go. If we have P or 1P plus 85 thousandths P, then that equals, for like terms, you add the coefficients, 1 and 85 hundredths P.